This is a video about how to put gas laws into the mole map. So it's stoich and gas laws all at the same time. So I want to take a little step into the mole map first. So far what we've learned is going from liters into moles and moles into liters, this part right here. This would be what I'm going to call my aqueous lane, and this lane over on the other side is going to be the gas lane. So if you've got a state of matter of your substance you're dealing with that's aqueous, you're going to use molarity. Molarity is moles per liter. That's what we've already looked into. But now we're looking at gas, because gas laws are coming in, and you can't use concentration or moles per liter for the gases. Here, you've got to use some sort of gas law equation, and there's really two options. Either you're at STP, or you are not at STP. If you're at STP, then we know that at STP, 1 mole is equal to 22.4 liters. That's on the AP sheet, so it's nothing you need to memorize. They say at STP 1 mole is 22.4 liters, and that's true for any gas, even a mixture of gas. Now, if you're not at STP, then you can't have a straight conversion factor because you've got different pressures and different temperatures. So that's when you have to use Pivnert. So I'm going to show that to you with these two different problems here. So keep in mind that these two different kinds of lanes here on the left really are the same thing that are applying here. Here's my gas lane, and this one would be my aqueous lane. Okay, so let's look at number 1. If you use 25 grams of propane and excess oxygen, that's important, excess, so we know that propanes are a limiting reactant, how many liters of carbon dioxide will you make at STP? Okay, so for number 1, I can just use straight stoich for this. I can go question mark liters of CO2 equals 2.5 grams of propane, C3H8. So if you look on the mole map here, I am in grams, and I'm trying to get to liters of different substance, so I have to go to the green side, get into liters. So I'm going to go 1, 2, and 3 to get there. So I'm going to put grams of C3H8 on the bottom, and mole of C3H8 on the top. 1 mole of C3H8, if I use the periodic table number, it's 44.094. Now I'm going to convert out of moles of C3H8, and into moles of CO2, because that's a substance I care about. That's my second step. To do that, I need the balance equation, which I have. I've got a 1 by C3H8, and the CO2's got a 3. And then my last step, if I can go over this here, is to look at, get out of moles of CO2, so they can cancel. We're doing this last step, and we're going into liters. Now I am at STP, and it's a gas. CO2 we know to be a gas, so I can use this conversion factor, where 1 mole equals 22.4 liters of CO2. So just got to push things in my calculator. My calculator says 3.81, so looking at 2 sig figs, I need 3.8 liters of CO2. And that's my answer. I'm good. But let's take a look at number 2. Here's number 2. If you use 0.52 moles of propane and excess oxygen at 25 degrees Celsius and 852 torr, how many liters of CO2 will you make? Now this problem from the start, you see you've got moles, you've got temperature, you've got pressure, you're just going straight Pivnert on this. But the problem you always have to look at is you have moles of what substance? Propane. And you're trying to get liters of what substance? CO2. Anytime you're going from one substance to the other, you have got to use the mole map. That's the only way you can get from one substance to the other. So that is the first thing I should do. I'm going to ask myself, well, how many moles of CO2 do I have when I have 0.52 moles of that propane, C3H8? So what I've got for this problem is I'm starting in propane moles right here. And in the end, I'm going to try to get to liters of CO2. Now the thing is, I'm still going to go 1 and then down makes 2. But the problem is that I'm not at STP, which means I have to stop here at the moles. That one's got a stop sign for it. So you have to stop at moles of the substance, so right here, and then I can use Pivnert. So that's why I'm asking myself not how many liters of CO2 I have. I think it's easier if you go how many moles of CO2 do you have, and then use Pivnert. So here I'm trying to get out of moles of C3H8 and into moles of CO2 like we did before. And there it's that 1 to 3 ratio. If I push the numbers in my calculator, I get 1.56 moles of CO2. I'm going to keep it as 1.56 even though I know that there's only 2 sig figs, because I'll take that into account later. Because next what I'm going to do is I stopped here, now I'm going to use Pivnert. PV equals nRT. I'm going to fill in all these blanks here. Alright, So now I've got that 1.56 moles of CO2. That's what's going to go right in here, 1.56 moles. That's my N. My P will start at the beginning here is 852 torr, 852 torr. My V is what I'm trying to solve for. Here's my N, here's my R. R is a gas constant. It is on your equation sheet. I'm going to pick the 62.361 because that has units of liters times torr, which is totally what I'm in, over moles times Kelvin. So my torr will cancel, my liters will cancel because my volume will be in liters, my moles canceling, and here's my Kelvin. I've got 25 degrees Celsius, so 25 plus 273. And now I just got to solve for V by pushing numbers in my calculator. Whew. I have a sneeze, sorry. So if I use my calculator, I get a number of, excuse me, 34.026. Sig fig wise, if I look into it, remember this 1.56 should really be 2 sig figs, so I got 2 sig figs for my answer, or 34 liters of CO2. And that's my answer. So looking at gases, always think to look at states of matter you've got. Aqueous, we use molarity. Gases, we're going to use these two different conversions, depending on if you're at STP or you're not.